when you are ready to study for your exam, make sure you have all your notes with you so you can look through the notes and then use the in-class exam practice and practice those questions. After that, we have an extra exam review package. You can use those questions to practice some more. For 9.1, we talk about limits. Several key points you want to remember, including when you look at a graph, limits only exists. So if we are looking for limits as x approaching to a, what is the y value? Limits only exists if it's coming from the left and right. As x approaching to a settle at the same y value. So that's the only time your limit exists. If going from the left and from the right, as x approaching to a, y settle at two different numbers, then your limit does not exist. We use d and e as the notations. We also talk about if as x approaching to a from left and right, if they are either approaching to negative infinitive or positive infinitive, then your limit does not exist, okay? And also the notation, if you see a plus sign next to the x value, that means coming from the positive side, so it's coming from the right-hand side. If you see a negative sign, it means coming from the negative side of x, so it's from the left. So negative is left, positive is from the right. Also, if you don't have a graph and you want to find limits, the step will be we should try to plug in the x value. That would be the quickest way you can find the limits, but sometimes that does not work. What I mean by not work is if you get a denominator equal to 0, that would be undefined, right? Or if you have a negative value under the square root or even roots, it will come with I or not a real number. Then those two situations, then you will move on to the second step, which is try to factor and reduce it before you plug it in. Sometimes that will work, that will be quicker, but if both of these steps did not work, then you will move on to the last step, which is setting a table and see how the x is approaching from the left and right to decide the limits. So 3 steps, plug in number. If it doesn't work, factor and reduce. If it doesn't work, set table, okay? So that would be basically your 9.1. So for 9.2 is infinite limits or limits approaching to infinitive. So this one, sometimes we can see this graph as x approaching to infinitive, y settled to certain values. This guiding line, we call that horizontal asymptote. In 9.2, we review some of the concepts, including the end behavior of polynomial functions. Those are from the first business math class. So if you don't remember that, please review that a little bit. All the polynomial function, the graph will look very smooth and continuous, so it's not discontinuous anywhere. We also look at the rational function, the function that look like a fractions, and review how to find the asymptote. So you may want to review those if you have some question, because the vertical asymptote is setting the denominator equal to 0 that help you to decide where the function is going to be discontinued. And a lot of time the horizontal asymptote, which is setting y equal to the leading coefficient on top and leading coefficient at the bottom, those seems to help you to find like limit as x approaching to infinitive or negative infinitive, where does the y value settle. In addition to that, we also did some of the limits as it approaching to infinitive with our graph. The strategy is you need to divide top and bottom each term with x raised to the highest power from the bottom part. So like this one, we probably need to divide it by x to the first power, right? That's the highest power from the bottom part. This one, we're going to need to divide each part with x to the 6th, because that's the highest power. And any term toward the end with an x in the denominator, because it's approaching infinitive, that term is going to turn into 0. So that will help you to solve those problems, okay? So that would be 9.2. 9.3 is talking about where does the graph continue or discontinue. So it's continue if there is no open circle, no jump in the graph, no break in the graph. It's not continue when you see open circle, jumped, or like a break in the graph. Okay, so some of these you will have to decide where is it continue or discontinue. So just like what we said earlier, anytime if you see polynomial function, it's going to be continue everywhere. But if you see like a rational function, by taking into consideration of the vertical asymptote, then you can find out where is the function is going to have a break or discontinue. Okay, so that's 9.3. 9.4 is taking the derivative with the 4 steps. So derivative is the slope of tangent line. So 9.4 is taking derivatives. We are interested in the rate of change, which is the same as the slope. And we talk about tangent line. The tangent line is the line that barely touch the curve, just 1 point. And the secant line is the line causing the curve 2 times, like 2 points here, form a straight line. So we did a lot of rate of change from 9.4, and we want you to remember when you try to find the slope of secant line, you're finding the difference of quotient without taking the limits. But if you want to find the slope of tangent line, it's finding f line of x, is taking limit as h approaching to 0 and the difference of quotient. So when you're talking about slope of tangent line, it's the same as f line of x, y prime, dy dx, velocity, instantaneous rate of change. So here they kind of mention it, the average rate of change is the slope of secant line. The instantaneous rate of change would be the tangent line. So we did the 4 steps for multiple questions, so you will have at least 1 question like that on the exam that asks you to perform the 4 steps. We have to know how to do it because this method always work. So next, we are going to move on to the shortcuts. So you can use f line of x and taking limit as h approaching to 0 for the difference of quotient to find the slope of tangent line. This always work, but if you have a function that's differentiable, meaning there's no sharp corner in the graph, there's no gap, there's no vertical slope for tangent line, those you can try to use the shortcuts, and there are a few rules that we have learned so far. The first one is if you're taking the derivative of a number, a constant, it will turn into 0. Second one we did is if you're taking the derivative of just x, it will turn to 1. If you're taking the derivative with x raised to n power, basically you bring down the exponents and the exponents go down 1. So when you do like x to the 8th, it go down and the exponents turn to 7. So that's the second rule. A lot of these you're going to need to first rewrite them as exponents before you taking the derivative. Okay. The next rule talk about if you have a number multiplied to a function, so you let the number hang out for a little bit and just take the derivative of that function part. For example, this one, you let 5 sit there for a little bit, x to the 3rd power is bring down to 3, x to the 2nd power, right? And then you can multiply them together. And the next rule is the sum rule. Basically, you just take the derivative of each part between the add and subtract sign. And the next one, for this kind of question, a lot of time they will ask you to find the slope of the graph. So you will take f line of x, and then if they want the slope at certain point, then you will plug in those number in f line of x. When you have to find the equation of the tangent line, then you need a point and a slope. So make sure when you find the y value of the points, you plug into the original function. But if you need to find the slope at that point, you plug into f line of x, okay? And when they talk about slope of tangent line is horizontal, means the m equal to 0. And then you can solve for x for that. So that's 9.5. And then we jump to 10.3 because we are going to move the log and ln step to the second exam. 10.3 have a few new rules. One is product rule. The product rules say you should put the first part of the function, take the derivative of the second part, and then you do additions. Second part of the function, take the derivative of the first. Like this one, you write down the first part, take the derivative of this guy, adding, write down the second part, take the derivative of the first, and then simplify, right? So that is your product rule. We also talk about quotient rule. So quotient rule, you have to be careful. The order does matter. If you have a fraction like this, make sure you square the bottom parts. Start with the bottom, take the derivative of the top. This time we are doing subtractions. Put down the top part, take the derivative of the bottom. So make sure you practice a little bit. That would be for 10.3, and 10.4 is the last section for exam 1. We talk about the chain rule and then the combination of chain rule with the sum and differences, product, and quotient. So the chain rules say you need to take the derivative of the outside parts times the derivative of the inside parts. So what they mean by that is, say we have that, so you want to take the derivative of the outside, meaning pulling down the 2, the exponents go down 1, and then you take the derivative of the inside part. This can be combined with, sometimes it's the add and subtract rule, and then sometimes it's the multiplication rule, and the chain rule with the quotient rule. So again, like some of the question will ask you to find the slope, which is f prime of x, and then slope at certain point, then you plug in the point for f prime of x. If they ask you to find the equation of the line, you need the slope at that point and also find the points. When you find the point, you plug in the x to the original function. That would pretty much be the things we want to test you over for exam 1.